Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the Technical Session 5A. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 8th World Conference on Smart Trends in Systems, Security and Sustainability, WS4 2024, London, UK. The 8th edition of the conference is being held in the hybrid mode. The physical event was organized on 23rd July in London, UK, and the virtual event is being held through Zoom from 25th to 26th July 2024. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we will have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected to us till the closing remarks. If you have any query or any updates, then you can write it to me in the chat box below. Just before we get started, I would like to introduce you all to the session of this chair. So we have Dr. Nilesh Modi, Professor and Director, Dr. Baba Saheb Ambedkar University, Ahmedabad, India. Dr. Nilesh Modi is having rich experience of around 17 years in academics and IT industry. Presently, he is working as a professor and director, School of Computer Science, controller of examination, and NAC coordinator at Dr. Baba Saheb Ambedkar Open University, Ahmedabad. He is holding expertise on cybersecurity and certification on ethical hacking. Welcome to the session, sir. Would you like to share quick opening remarks with us?
Hello.
Yes, sir.
Hello. Yeah, I'm audible.
Yes, sir, you are audible.
Yeah, Anshika, thanks for welcoming me for this international conference, 8th World Conference on Smart Engine System Security and Sustainability. So I'm glad to be the session chair for this session, and let's have a very good conversation with the research scholars. Thank you.
Thank you so much, sir, for joining us. I would also like you to introduce to our next session chair, Dr. Abdul Wahab Sahamad, lecturer at the Institute of Business and Information, Kosgro, 1957, Indonesia. Sir has worked at Indonesian Parliament as an expert at Commission 19 from 2010 until now, and a lecturer at the Institute of Business and Informatics, Kosgro, 1957 since 2019. He has many international research publications and books for about 32 publications from 2019 to 2024, such as Scopus, Ebisco, Coprins, and etc. Welcome to the session, sir. So, now we would like to start with our first presentation. We have Semena to present her paper titled A Data-Driven Approach for the Optimization of the Fuel Mix for Sustainable Cement Manufacturing. Are you there, ma'am?
Yes.
You may start
Hello.
your presentation, ma'am.
Okay, let me share my screen. Okay, can you see it?
Yes, ma'am. We can see your screen. You may start.
Thank you. Okay. Oh, sorry. Hello, ladies and gentlemen. My name is Samaneh Khatai Muqaddam, and I come from a small city in northeast of Iran, known for being the biggest producer of saffron in the world. Unfortunately, during last 7 years, we face a huge decrease in saffron production because of the reduction in the snow and also rain. This decline is not just a local concern, it's connected to larger issue. Yes, climate change. Climate change is happening right now and affecting our daily life. Therefore, climate change has promoted widespread concern in between the different among the governments and for example, United Nations of Climate Change has also European Union has really concern about the climate change. Therefore, as a part of this ongoing effort, carbon pricing has been instituted, and this helps. Put some. Sorry. By putting price on carbon cost of emitting shifts toward emitters. Today, I want to discuss how we want to tackle this to tackle this problem. Starting off with an introduction, we'll then discuss the challenges the European cement manufacturer faces. After that, I'll go through what other researchers have studied so far, and then I'll explain how we conduct our research and also highlight conclusion and finally suggest recommendation for future work. The cement industry ranks among the most significant contributor of CO2. Approximately 580 kilograms of carbon dioxide is emitted per ton of cement. 60% of this comes from the calcination of raw material, 10% attributed to electricity consumption, of 30% comes from burning fuel. And today we'll explore how this changes, how we can address the challenges of burning fuel in the cement industry. And the focus is on replacing fossil fuels with the fuels with high biogenic content, and also to tackle the both environmental concern and also cost effectiveness. The challenges that cement industry facing right now is that the cement landscape is dynamic with fluctuating fuel prices and also dynamic market availability, and also with CO2 certification, changing the CO2 certification prices and also evolving emission rules. Unlike typical research, our study takes another distinction. We gather the information from from global concept, and then we integrate them to the local area. For example, we gather statistics about carbon emission, about cost from the sources like as GRC technical report, International Energy Agency, and European Cement Association, and also Greenhouse Gas Protocol and European Emission Trading Scheme. And also we search Elsevier Scopus. For example, Afterheide and Dimetio emphasize the technical difficulty in using alternative fuels. Joseph and Obede made an model with MATLAB, and they evaluate the influence of fuel mix, including conventional fuels on production of clinker production quality. And finally, Inoz and et al. Made an optimization mathematical model for raw material and the effect of raw material and fuel in the cement production. Within the company, we meet different stakeholders, and also through company organized seminar and visit different cement factories and waste producer. We gain insight into really great insight into a factor that's shaping our fuel mix optimization. The existing model are lack of adhering to actually adhering to a predefined fuel mix and also relying on average value and lacking real-time data. So we already discussed that the cement industry is dynamic, so they can't fit to these challenges that cement industry is facing now. Our use model is a cross-industry standard process for data mining. It includes 6 phases: project understanding, data preparation, modeling, evaluation, and deployment. In following slides, I'm going through them. During project understanding phase, we have 3 sections that we started our with literature review. Then we went to challenges the cement industry, specifically in cement in Germany we're facing. And then we define our scope of project, which is a cement clinker producer containing 20,000 clinker ton of clinker per day. And also, and finally, we define our goal for optimizing, which is reduction the cost and also reduction the carbon emission. During the data understanding phase, we gather information, the information that affect our fuel mix model. These factors are price for secondary and primary fuel, market availability of each of these fuel, and also facility infrastructure and operational strategy, and fuel specification data, and also process limitations such as the maximum, for example, allowable sulfur that is in the main burner or calcined lake. And moving into the data preparation phase, as the data from the comes from the somehow pre-validated sources such as SAP or other company reports. So we narrowed our focus on some statistical consideration. We gathered information from the most used fuel, solid recovered fuel from in a representative plant from different sources. As you see, there are a huge difference between both fuel prices and also chemical specification between this data set that is containing 17 points. So we decided to put our model based on supplier and fuel type. Now transition to the modeling phase. Here you can see how fuel specification, fuel prices, market availability, and infrastructure, and also operational strategies such as recorded in different burning area can affect our optimization model. This optimization model is based for our mathematical calculation in the next slide, which is our Excel tool. Moving forward to our Excel tool, we actually set up our Excel tool. We define our optimization decision variable, which is the capacity of each fuel type obtained from supplier S. Also, we define our objective, which is the minimizing the total fuel cost. And we define our optimization parameters, which is including the production and operation constraint, heat distribution, fuel characteristics, and also process limitation. Continuing with our optimization constraint, here is the heat balance constraint that we want to be sure that the supply heat through different sources such as primary and secondary fuel, and also in different burning area, need to be equal to what the plant needs based on their operational strategy. Moving forward to another constraint, which is capacity constraint. This capacity constraint is, first of all, we need to be sure that they are positive, they are not negative. And then in the second phase, we need to be sure that this capacity are below the maximum allowable capacity that comes from infrastructure constraint. And in the next step, we define the secondary fuel quantity constraint that shows the number of secondary fuel that can be used simultaneously in the plant. And finally, we have our process constraint. Here, we define some limitation about the amount of heat calorific value can be introduced to different burning area, or the minimum value of the maximum value, allowable value of sulfur, caloric, or humidity that can be introduced through different burning area. And before I go through our result, I would like to highlight that our tool follows two approaches: evaluation approach. During evaluation approach,
Sorry to interrupt you, ma'am, but you have 2 minutes to conclude your presentation.
Okay. During the evaluation approach, we consider market availability, facility, and prices, and this somehow helps us to provide some initial value for our model. And during the optimization process, we add some other limitations such as process and fuel. We use solver model. Solver model is we define our variable, objective, and constraint, and also we selected solving method, which is the general reduced gradient. And our tool, this is our tool our tool needs some data entry from user, and after that it helps user to provide, but by visualization the cost and also CO2 emission helps user to make the best decision. Moving on to our result, we compare the result of our tool outcome with the representative plant current situation in November 2023. Our tool shows that it can help the plant to increase the secondary fuel rate up to 20% around, reduce the emission by 70%, and also fuel cost by 23%. Also our tool can help the user to use different scenario. For example, in the first scenario, we have 49% using fuels in the main burner, and the second one 53. It's compared that with in the first scenario, we have the possibility of increasing 30% of secondary fuel rate, 30% reduce in carbon, and also 22-point cost reduction. I would like to mention that our tool just collaborate with user and it's not dictate. It receives some input data and respect the data entry from the user. For example, they define how many percentage of use they want to use in main burner or cache signer, or also even they can define their availability infrastructure and from maintenance point of view, and then with visualization the cost and representing CO2 corresponding impact helps user to make the best decision. And for the future work, this is it can be one of them can be focusing on minimizing CO2. Although our tool somehow minimizes CO2 because it's the focus is on, but it can be introduce another model that for its initial focus be on CO2 and also, as this secondary raw material is hugely affect the CO2 emission because of calcination, another model can be focused on raw material, secondary raw material, and last but not least, the determining specific fuel parameters during production also can helps to shift the focus toward in the factory shift focus toward the quality. Thank you. Sorry that was too fast and I had some problem with my presentation, and yeah, any question?
Thank you so much, ma'am. Sir, do you have any questions?
Yes, and what data set did you use for this research and for data analysis?
For data analysis? For the data analysis, actually, we used just Excel solver. I emphasize that the data in the company was somehow pre-validated and was cleaned. So we just need to bring the data and do some mathematical work and offer them the best solution and optimize them via Excel solver. We define some constraint there, and what I did, I use the first approach, that is evaluation. It's just to provide some initial value for model to help model toward the best solution and avoid model to trap in the local minimum.
Okay, thank you.
You're welcome.
Thank you so much, ma'am. So we'll be moving on to the next presentation. Next up, we have Faisal Binsar to present his paper titled Analysis of Digital Content of Indonesian Society in the Public Service Sector. Are you there?
Yes, okay.
You may please start with your presentation.
Okay, thank you. Can you see my screen?
Yes, sir, your screen is visible. You may start.
Okay, thank you. Good morning, everyone. Thank you for joining us today. We are pleased to present our paper title, Analysis of Digital Content of Indonesia Society in the public service sector. Our team consists of Faisal Binsar, Muhammad Bayu, Irfan Abbas, Arif Budiman, and Abidah. We appreciate the opportunity to share our research with you. Let's begin the presentation. This is the outline of the paper that we will discuss in this presentation. And this is the abstract and keywords of our paper. Introduction. Public services are fundamental to societal well-being. They encompass various sectors such as healthcare, transportation, education, and administrative services. The digital age has transformed how citizens interact with and express their opinions about public services. Our research focuses on analyzing this digital content to gauge public sentiment. We aim to identify strengths and weaknesses in public services based on online discussions, providing actionable insights for improvement. Literature review. These services are vital for ensuring economic stability, providing access to essential services, and enhancing the overall quality of life. Resource constraints. Public services often face limited budgets and resources, making it challenging to deliver high-quality services. Bureaucracy and inefficiency. Complex administrative processes can lead to delays and inefficiencies in serving provisions. Accountability and transparency. Ensuring that public services are delivered transparently and accountably is crucial for maintaining public trust. Digital content analysis. Digital content analysis involves examining online content to gain insights into public sentiment, trends, and key issues. It is crucial for understanding real-time public opinions and behaviors, which can inform decisions and strategies. Sentiment analysis. This method uses NLP, natural language processing, to detect and interpret subjective information from online content. Thematic analysis. This qualitative method identifies recurring themes and patterns in data, helping researchers understand underlying meaning. This research focuses on digital discourse around public services, identifying how this topic becomes a major subject of conversation on internet and social media. Then 24 issues to monitor various platforms, focusing on the keyword layanan public over a 1-month period. Atlas.pi is used to support transparency and systematicity in the analysis. We use metrics, mentions and reach. Mentions the number of times the topic is mentioned in digital environment. Reach the number of people or accounts who can see the content. The analysis process involves several stages, including coding, grouping codes, and creating themes. Atlas.pi is used to support transparency and systematicity in analysis. This process involves reading the text line by line, generating quotes, and coding to understand the digital discourse deeply. The total number of mentions obtained from this keyword reached 2,673, with diverse distribution across various platforms such as Twitter, news, forums, blogs, videos, TikTok, Facebook, and websites. The development of mention and reach every day is shown in this video. Analysis of public services produces several sentiments, including negative and positive sentiments. Sentiment analysis of these mentions yielded an understanding of public response to public services. Discussion aspects. Further data analysis was carried out using atlas.ti by reading all social media posts and extracting the subject of each content. The posts were classified by service area. The field of public administration is the main focus of society, followed by the fields of education, economics, and then transportation. In the economic and financial fields, public services include tax and banking services. Results in public service sentiment. The result of the public service sentiment analysis provide positive and negative information that can provide benefits and evaluation materials for service providers. Positive sentiment in the review generally contains appreciation, recognition, and aspirations to improve the quality of public service. Meanwhile, negative sentiment in the process and implementation of services can be seen from additional cost charge. In addition, the service is long-winded and the gap in access to public service result in injustice in the distribution of wealth, income, and social benefits. The discussion of this study provides several discussion results. General service category highlight the positive reception and appreciation for government efforts. Positive sentiments discuss the positive impact of infrastructure implement on public perception. And negative sentiments address concerns about inefficiencies and practices like extortion in public services. Critic and business-oriented approach to public transport and infrastructure. The next, health services address criticisms regarding health insurance registration and regional hospital services. In other public services, highlight security concerns and preferences for more stable digital service platforms. The conclusions of our study highlight the importance of public appreciation and areas needing improvements, emphasize the role of feedback in shaping better public services. In dealing with these findings, the government and service providers need to respond proactively to criticisms and community expectations. Through appropriate responses, it is hoped that public services in the various sectors can become more effective, efficient, and responsive to community needs. Here are 10 of the many literature studies we use for this paper. We use key insights for each study and how they contribute to our understanding. Thank you for your attention.
Thank you so much, sir, for your presentation. Sir, do you have any questions?
Yeah, hi Faisal. So, my only concern content is that what sort of data you use for influencing the people in the public service sector?
Yeah, thank you for your attention. We use the data online from social media like Twitter, website news, video like YouTube, TikTok, Instagram, and so on. We get this data from Brand24 application platform that give us some many data source for general platform like Twitter, Facebook, and so on.
So Faisal, how did you means separated the data? Because there might be in the Twitter, now it is X. So there are plenty of tweets available. Okay, and 20 of the posts that users have made. Okay, some are in the positive sense, some are in the negative sense, and some are in the neutral sense. And there might be the possibility that many of the tweets that are some sort of irrelevant. Okay, so how exactly you separated and segregated all these data? Have you developed any algorithm,
Okay,
or
thank
have you
you.
used algorithm?
Okay. We use our data from Brand24, but Brand24 application use some modules like to group sentiment analysis with a positive, neutral, and negative sentiment for all languages in the world, like Indonesian and English. And then we use all of message. We process it by using atlas.ti to get insights and then to process content analysis in the next process. So we get the insight, we get the information about themes that citizens discussion about.
Okay, thank you.
Thank you
Thank
very much,
Thank
Professor.
you so much. So we'll be moving on to the next presentation. Next, we have Zainab to present her paper titled Control the Speed of Switched Reluctance Motor Based on PID Controller. Are you there, ma'am?
Yes, hi everyone.
You
It's
may
me.
start with the presentation, ma'am.
Okay. Just a minute, please. Good afternoon, everybody. I'm author in South Electric student, Electric University in Iraq. My title paper control the speed of switch reluctance motor based on BID controller author Zainab Fadel Ali and Dr. Isa and Dr. Dia. Important of light in this presentation: introduction, challenge in switch reluctance motor speed control, proposal, methodology, result, and conclusion. Introduction: the speed switch reluctance motor information type of electric motor, effective and very stably operating on principle. Magnetic reluctance, the switch reluctance design of switch reluctance motor, simple design compared with the other type of motor make the reliable and cost-effective solution or various application by elements to need prevented magnetic or field on switch reluctance motor, radius maintenance requirement with the development of high torque, density, and efficiency. Switch reluctance motor use in electric vehicle, robots, and renewable energy data efficiency operation and ability to highly rebate a load challenge. Operation on the motor symbol. Switch reluctance motor consists in two parts. The fixed part is stator pole and the moving part is a rotor. The fixed part consists on the end 9 poles and the moving part consists in 6 poles. When the rotor magnetic reluctance is applied on the stator, which of rock is created by the rotor magnetic to pole rotor with adjustable pole. The rotor will are switched sequence with the help on the electrical control system is the connect reaction sequence and the minimum the number of switch per phase. The switch reluctance motor have two operation system is forward rotation is sequence A, B, C, D, and the forward the A, D, C, B. Challenge in switch reluctance motor non-linear operation in reverse element fork make speed control difficult achieved smooth and principal speed. Switch reluctance motor, a dynamic instability causing torque ripple and noise. It's a challenge in speed and control torque ripple. It's challenge in speed control, relate smooth operation like. The proposal and objective introduction motor, building a mathematical model of switch reluctance motor in MATLAB simulation, sensor feedback system, such as a position and speed sensor, improve speed for switch reluctance motor by the BID controller parameter, the motor performance. The complete dynamic mathematical model of switch reluctance motor, a differential equation are obtained use standard electromagnetic theory. They three equation is the base in building switch reluctance motor, induction equation and the volt equation and the torque equation. Implement in switch reluctance motor in MATLAB with BID controller, this control circuit and drive circuit, switch reluctance motor circuit contained in 4-phase, 8 stator with 6 rotor. الBID controller content a 2 manager control, the speed I reference control and the speed theta control. The speed reference control, the error is different between reference speed and actual speed. Drove the parameter BID, KB will KI will KD to result I reference. The same stage in the speed theta of control error between the speed reference speed and actual speed. Draw passes the parameter PID controller KB will KD will KI to result theta of effect parameter of the BID, KB والKD والKI and the closed loop system. KB decrease the rise time, increase the overshoot, decrease the steady state error. I decrease the rise time, increase overshoot, increase the steady state time. KD a simple change, decrease the overshoot and decrease the steady state time. Some result you get when the set sequence of voltage current with the ABCD at 20 degree mechanical shift angle. Speed reference is positive 1500 IBM. You get a mechanical rotor speed at no load and steady state developed torque. This picture rotor speed with load when the value of load is 3 Newton per meter at 7-second time. This rotor speed at load and steady state develop torque with error. At the case inverse, when the sequence rotor operation switch reluctance motor A, D, C, B, they here mechanical rotor speed when the speed reference speed is minus 1500 RPM at no load, the steady state development torque This rotor speed with the load when load minus 3 Newton per meter at 7 time steady and steady state develop torque at 3 load. When change is speed, the reference is change between from 1500 to minus 1500 RPM. Conclusion, use MATLAB software, grade and test Simulink model BID controller for switch reluctance motor, the proposed Simulink model for phase switch reluctance motor. Results show performance for proposed control model apply to change reverse speed. Choose the parameter BID controller by try and error. Thank you so much.
Thank you so much, ma'am. Sir, do you have any questions?
No more question from my side.
Okay. So next up, we have Jen Andrew to present his paper titled Cultivating Futures, Integrating Hydroponic Gardens into Educational Curricula for Community Resilience and Intergenerational Learning. Are you there, sir?
Hello, good afternoon. Yes, I'm here.
Okay, sir, you may start with your presentation.
All right, let me just share my screen.
Yeah.
All right, is it all good? Do you see it?
Yes, it's all good, sir. You may start.
All right, thank you. First up, for us, every seed is an investment for the future. Good morning, everyone. My name is Andrew, and today we'll be presenting our paper entitled Cultivating Futures, Integrating Hydroponic Gardens into Educational Curricula for Community Resilience and Intergenerational Learning. This has been a collaborative work for the Ateneo Innovation Center of the Ateneo de Manila University and our partner institutions. First up, just to set the setting, the Philippines has traditionally been an agricultural country. However, with over 54% of Filipinos now living in urban areas, we are experiencing a significant decline in the number of farmers. The average age of a Filipino farmer is between 55 to 59 years old. And experts say that they predict that a critical shortage of farmers in the next 10 to 12 years. This poses a severe threat to our food security and rice self-sufficiency. So additionally, the Philippines has been identified as the country most vulnerable to climate change and extreme weather events. Thus, it further, complicates our agricultural challenges. Thus, we thought of there's a need for innovative measures to build community resilience. So just one of the tools of addressing those issues amidst challenges of extreme weather conditions, typhoons, and floods that disrupt food security, rising costs of farming inputs, and urbanization. We saw smart hydroponics as one of the viable tools for innovation. It enables efficient use of space for urban farming, and also it offers resilience against climate variability. By leveraging near cloud technology for offline data processing and IoT connectivity, smart hydroponics to be exact, supports precision agricultural practices. So also we wanted to engage the young generation as we envision this to be one of the potent tools in addressing the aging population of farmers and then promoting sustainable agriculture, like that planting seeds for the future of agriculture in the Philippines. To discuss more about this smart hydroponics, our system implements a star network topology using LoRa-based sensor probes to monitor essential growth parameters like that you see listed on the left side of your screen: temperature, moisture, electrical conductivity, pH, nutrient levels, including nitrogen, phosphorus, potassium, and then salinity. The figure that you see on the right of your screen tells you that the sensors sample data at the specific intervals, and then they transmit it to a gateway node, a LoRa gateway node, which then sends the data to cloud platforms like that of ThinkSpeak, and then or if offline, field servers like that of running on near cloud. Its dual monitoring mechanism, offline and then offline, allows for continuous monitoring where connectivity is sparse, especially in the case of the Philippines, where an average of 20 typhoons bring damage every year. So it also is suitable for places like far-flung rural areas where internet connection is still hardly available. So this model or process then generates and allows for precise and real-time monitoring of the hydroponic systems. It automatically generates charts, and then these charts can be viewed and customized according to the different periods of time. Just to discuss other relevant features of the smart hydroponics, we have developed a low-cost greenhouse setup that reduces costs by 25% while maintaining the same nutrient solutions efficacy as commercial alternatives. It's important for us to reduce the costs because we're working with schools, and we wanted to allow them to be able we wanted to be able to reach more schools, and then also allow the schools to be able to at least give their counterparts and afford these greenhouse laboratories and hydroponic system. And also by using blue LED panels as an alternative light source, we can address prolonged periods of low sunlight and then maximize the greenhouse space, especially if we're installing overlapping horizontal and vertical beds for seeds. Our Smart Heart Greenhouse Laboratory at the Salupungan National High School in Candaba, Pampanga serves as a practical example of integrating this to the school activities and to the curriculum. The Ateneo Innovation Center's deployment of a smart greenhouse laboratory in this high school in a town called Candaba and in a province called Pampanga in the Philippines, it essentially demonstrates application to real world scenarios. And these initiatives not only enhance academic learning, but also promote smart hydroponics as a sustainable agricultural practice. This smart greenhouse laboratory was constructed in partnership with the school. It's a 3-meter by 3-meter greenhouse complete with shade netting, UV plastic, steel bars, frame, and then we assembled and equipped it with our sensors and then the monitoring system. We were able to demonstrate to them and then conduct hands-on training on the preparation of the growth media, styrofoam boxes, and cups, all these things, the right dilution for the nutrient solutions, and then the proper way of seed germination, transplanting, and harvesting through a series of workshops and then interactions with the students and then the teachers. So until now, the teachers are able to manage these greenhouse laboratories and then involve the students in maintaining these greenhouse labs and then planting seeds as well. In terms of involving the grade school, the lower portion of the basic education curriculum, we worked with the Ateneo de Manila Grade School, doing the similar initiatives. The smart hydroponics was first introduced to the parents and then to the teachers through a workshop which the Ateneo Innovation Center conducted. So the teachers learned how to incorporate hydroponics into its curriculum and then plan and decide how these things are going to be integrated with the school works. They also underwent hands-on training and went through the entire cycle of germination and then harvesting. Currently, a greenhouse with platforms intended for hydroponics was eventually constructed inside the grade school campus. Just to discuss the recent updates, so the high school that we were talking about earlier, we extended the partnership with the community where the school was located. We were able to discuss and made discussions with the local government, village local government in the area. And then we were able to deploy a near real-time weather station in partnership with the Boston College of Engineering. And then we continuously meet with the farmers and the officials of the village as we have finished setting up a hydroponic system with artificial light support for the community. Just to discuss the initial outcomes of the study, schools now have access to smart greenhouse technology and hydroponics. So this also increases both the teachers and the students' competencies in smart agriculture. There's also a growing interest among students in the nexus of technology and agriculture. So it's a win for us. We've also established a model for the most important thing is that we have established a model for promoting smart hydroponics through partnerships with educational institutions, highlighting this for potential community resilience and intergenerational learning. So it's important for us to establish that model so that eventually we will be able to scale it up. Our future direction includes integration of smart hydroponics into the educational curricula. And then we wanted to, looking ahead, we plan to explore environment-friendly soil amendments and then develop non-invasive monitoring technologies for crop health. We also aim to partner with more schools and then the Department of Education, the Ministry of Education, I think it's the counterpart in other countries, so that we'll be able to formally integrated into the curriculum. We understand that it's also not just it's not going to be sustainable if we're just going to work from one school with another. We understand it's better if we are able to integrate it more in a policy level. And then also we want to do an assessment and evaluation initiatives that will examine the impact of learning outcomes and students' interest in agriculture. But we wanted to do this if we're able to partner with more schools, just so we will have comparative data and then more data sample. Additionally, we seek partnerships with local agricultural organizations and then government units, just so we will be able to leverage resources and broaden support for our initiatives. And then eventually we'll be able to at least assess in a certain period of time if we're able to touch really on the nexus of technology, smart hydroponics, and then the desire of the students to learn more about smart agriculture and then eventually impact the population of farmers in the Philippines. That's about it. This is the I'd like to acknowledge this for the partners of our study, and then in the succeeding slides are our references. Thank you for listening. May every seed we plant cultivate a sustainable, inclusive future for every community, especially for those who are marginalized and most vulnerable. Thank you.
Thank you, sir. Sir, do you have any questions?
Yeah, Jen, good presentation. Hello, am I audible, Jen?
Yeah, thank you, sir.
Yeah, so it's a very good presentation. So how exactly you are looking forward for the moisture of these plants and everything in the smart hydroponics? Moisture related data. How exactly you are getting moisture related data? Yeah.
The moisture how are we getting the moisture related data, sir?
Yeah, how exactly you are maintaining through this ICD means in a smart hydroponics, how exactly you are maintaining the moisture? Because
Yes.
different plant needs different kinds of moisture.
Correct. Yeah. So yes, that's right. Different plants need different moisture. So for now, we're still working on three kinds of plants. We have lettuce, pecha. It's like a local lettuce here in the Philippines, and then tomatoes. So with the studies that we have made, we're able to at least test what kind of the amount of moisture that is needed for at least those three crops. And then there's also a system for water inside the greenhouse. So that is something that we also monitor.
Yeah, okay, thank you.
Thank you so much, sir. Abdul sir, do you have any questions? So we'll be moving on to the next presentation now. Next up, we have Reem to present a paper titled Enhancing Large Language Models for Improved Code Clone Detection, a Fine-Tuning Approach. Are you there, ma'am?
Yes, hello everyone. Let me share my screen.
Yeah, you may start with the presentation.
I'll talk about enhancing large language models for improving code clone detection. It will be presented by me, Reem Amin, is author and presenter, and the co-authors are Assistant Professor Dr. Rabab Farouk Abdelader, Dr. Ahmed Aid, and Dr. Mona Nashat from Egypt, Faculty of Engineering, Boursaid University. Our agenda for today is introduction to code cloning, our work overview, the traditional techniques for code clone detection, the deep learning techniques for code clone detection, and our approach for enhancing existing large language models for detecting code clones, the experimental results, and the conclusion in the future work. And at the end, we will take a look at the references. What is code cloning? The code cloning is duplicating some parts of the code in the same program or across different programs. Some developers may prefer doing this as they think that it may reduce time as it has no issues and it is working fine. But if some of this code, duplicated code, is need to be modified or has some issues, this will lead to a bug propagation across all the copied code, and also will affect the maintenance cost. The code cloning is divided into 4 types: type 1, type 2, type 3, and type 4. And based on the big clone data bench that the dataset that we are using in our approach, it is subcategorizing type 3 into 3 types: very strongly type 3, strongly type 3, and moderate type 3. These types are different from each other based on the differences between the source code and the copied code. We first explored the existing traditional techniques for code clone detection. Then we studied the deep learning approaches for code clone detection. And the last step was our approach for enhancing large language models for improving code clone detection. We will talk about each step in detail. The traditional techniques for code clone detection are divided into 6 approaches. The first approach is textual approach, which is comparing the text with each other. And the second one is a token-based approach, which converts the source code into a sequence of tokens and compares these tokens with each other. The tree-based approach converts the code to abstract syntax trees and compare the subtrees with each other. And metric-based approach that compares the metrics between 2 pieces of code. These metrics can be number of lines or number of variables. And the semantic approaches are converting the code into a program dependency graph and compare the nodes between of this graph between each other and to calculate the score, the clone score. And the last approach is hybrid approach that combine different approaches with each other. These approaches actually have some challenges, is if the code base is very large, there will be a very increase in the processing time because of the computational complexity of converting this code to a program dependency graph. And also, there are some sensitivity to semantic variations, as maybe a piece of code, 2 pieces of code appear that they are similar to each other, but functionally they are different. This will result in a high false positive and false negative. Also, token-based approach will be not effective in detecting other types beyond type 2 and type 3. It means that if the code becomes more complex, it will be more complex to detect the clone types, the code cloning, sorry. From here, the deep learning approaches appear to improve code clone detection. The leveraging of natural language processing with large language models has improved the code clone detection, as if the source code treated the natural language as a sequence of code, the models can calculate the similarity between the code fragments effectively. This enhancement in the natural language processing techniques results in highly robust pre-trained models, such as GPT, GraphCodeBERT, and Yonex Coder, where GraphCodeBERT and Yonex Coder are the two models that we used in our approach. From here, we thought how we can enhance these large language models for code clone detection. First, we prepared our data. We were using BitCloneBench dataset. This dataset is divided into dividing the code pairs into clone types, but they are dividing them based on the similarity score. So we referenced the similarity scores that they are documented in their documentation and processed this data to generate labeled data set with clone types. After the data is ready, we fine-tuned GraphCodeBERT and Yonex Coder separately. Then the models are able to detect the clone types. Then we have done our testing and evaluation. The experimental result, we generated the recall for each type for our baseline techniques that we are comparing with. And for our enhanced GraphCodeBERT, our proposed GraphCodeBERT achieved a perfect recall for type 1, type 2, and strongly type 3 and moderate type 3 against the other baseline techniques. And for the proposed Yonex coder, it surpassed Deckard and empty instruct in detecting strongly type 3, and it was the best one for detecting type 1 by 28%. Then we calculated the overall precision for the baseline techniques and our fine-tuned models. Our fine-tuned GraphCodeBERT was highly precise with precision score of 0.78, and the proposed Yonex coder achieved a better precision than Deckard and Vicona 7B. In conclusion, the existing code clone detection approaches face several issues due to high false and positive due to high false positive and negative rates. That's why we think to solve these issues by improving existing LLMs instead of that they are only detecting if the code pairs are clones or non-clones. We added a fine-tuning layer that makes the models able to detect also the clone type, not only if they are clone or not. We validated the efficiency of these models, and the evaluation results have shown the effectiveness of the enhanced models. Our proposed GraphCodeBERT achieved improvement in precision of up to 73%, and Yonex Coder achieved improvement in precision of to 42%. This is highlighting a significant improvement in models performance. And we are planning for future work to prepare a comprehensive data set from the Egyptian market, encompassing a wide range of programming language and diverse code examples. This will involve collecting extensive and varied programming samples to make to improve our models' performance. And we will study the effect of the fine-tuning process on more large language models for detecting code clone types. and also studying the effect of combining this fine-tuned large language models in a hybrid model for detecting code clone types. These are some of the references that we used. Thank you.
Thank you so much, ma'am. Sir, do you have any questions? So we'll be moving on to the next presentation then.
Thank you.
Next up, we have Madhubala Roy to present her paper titled Road Safety Using AI, Safety Index Formulation of Roads by Integrated Road and Road Traffic Violation Control System. Are you there, ma'am? Are you there, ma'am? So, I would sincerely like to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on the behalf of the whole team, thank you for your support during this 8th version and all the previous 7 versions of the conference. We will be happy to have in the 9th version in 2025 as well. All the presenters would be getting their digital certificates through mail within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2024. I also would like to thank our session chair, Dr. Nilesh Modi, for chairing this session. A token of appreciation for the chair on the behalf of the whole team, sir. We were really glad to have you. Would you like to share some quick closing remarks with us? So would you like to share some quick closing remarks with us? Okay. So I would also like to thank our session chair, Professor Abdul Wahab Samid, for chairing this session. So this is a token of appreciation on the behalf of the whole team of World S4 2024 and Global Knowledge Research Foundations and partners. So would you like to share quick closing remarks with us? Okay. So thank you so much, sir, for your valuable presence. Now I would request all of you to please open your camera for a quick snapshot. Everyone, please open your camera for a quick snapshot. Thank you so much, everyone. Thank you so much for your presence. Thank you.
Thank you too. Have a good one. Bye-bye.
Bye-bye. Thank you.
Thank you too.
Thank you.
Thank you.
Thank you.